So thus far we've looked at quite a few different equations for enabling us to calculate things about the vapor, dry air mixtures that you might have in HVAC applications. What we want to do now is let's try to bring some of these ideas together and look at an example problem. So there's our example program or example problem. We're told that we have a tank, 21 kilograms of dry air, 0.3 kilograms of water vapor, 30 degrees C, 100 kPa. They want us to determine specific humidity, that is omega, and the relative humidity, that is phi, and the final thing they want us to determine is the volume of the tank itself. So let's start proceeding through calculating this problem. What we will do, we'll begin by looking at the specific humidity, and in order to determine specific humidity, we will use one of the equations, the one that defines specific humidity, as being the mass of the water vapor to the mass of the dry air. Well, they give us that in the problem, so that's pretty straightforward. And so that gives us the specific humidity. Now for the relative humidity, what we'll do is we'll look at one of the equations that we came up with. Now here we know P because that was 100 kPa. We just solved for the specific humidity, so we know that. It's there again. PG, that we have to go into the steam tables in order to obtain. So PG is the saturation pressure at the temperature of our condition, which is 30 degrees C. So looking up in the steam tables, that gives us the value of PG. From that we can then get the relative humidity. And notice I kept both pressures in kPa. And we get 52.88%. The last part, they want us to calculate the volume of the tank. And the way that we're going to go about looking at this, we're going to use the ideal gas equation, but we know the mass of dry air. So what we need to do is figure out the pressure associated with the dry air. So that will be our approach. And given the definition of relative humidity that we had, we can determine the vapor pressure So this is the pressure associated with the water vapor in our mixture. And knowing that the total pressure, the mixture, is going to be a composition of both the dry air and the water vapor, we can then determine the dry air pressure. Knowing the dry air pressure, and we know the temperature, we can now use the ideal gas law. And what we want to do here, we're looking for volume, so let's isolate for volume. And if we look at this equation, we know the mass of dry air, we know the gas constant for air. Temperature, we were told the temperature of our gas, and we also know the pressure because we just solved that. So we have everything for this equation. I apologize, there's an error here. That should be 303 because our temperature is 30 degrees C plus 273, 83, 93, 303. So 303 K is the temperature. And then the pressure, 97, 755 kPa, and that results in a volume of this. So that answers part 1, 2, and 3 of the example problem, and it shows or demonstrates how we can apply these equations to working through a problem.